Hi, this is Peter Graining, and I'm the project leader for the FHIRFighters team. I'm back again after taking a hiatus from presenting to give you our final report.
Howdy, howdy, this is Tony Potter. Along with Shashinder Pradhan, Ali Sheikh, and Radha Venkatraman, we make the FHIRFighters team. Our project's goal was to build an interface linking death data to Utah's Directory of Clinicians. We worked with Paula Brown at the CDC as our project facilitator, and Jeff Duncan at the Utah Department of Health was our primary organizational mentor and contact.
Here's a final look at our project plan. We're in the home stretch, and aside from this presentation and the final delivery of our code, we're close to the finish line. Our business requirement was to provide a notification to Utah Medicare, also called the Division of Medicare and Healthcare Financing, about the death of a healthcare provider. Auditing discovered that they are paying out claims on controlled substance prescriptions from providers that have died. By providing death notifications, Utah can deny those claims and save money. The code we've developed could, in the future, be used to push general death notifications over a health information exchange, or on the other end of the spectrum, in an interesting twist, could send birth notifications.
It is important to understand process and data flow for our project. When a provider dies, the death event is registered in EDEN, the Electronic Death Entry Network, and the death event is going to be pushed to DOH MPI, the Department of Health Master Person Index, and it's going to link a death certificate to the provider in the Directory of Clinicians. Our job for this project was to take that provider info and transmit it to DMHF via a FHIR interface.
For our project, we had to research different topics that can be broken into two main categories. On the infrastructure side, we had to become familiar with PostgreSQL, the primary data store. While we learned a lot about FHIR through our coursework, there were still additional details we needed to discover, which we'll cover later. Java was considered for our programming language, but we chose Python since it requires fewer dependencies and we all had better experience using it. Later on, we had to research OAuth and authentication methods. From a conceptual standpoint, we needed to have a basic understanding of creating synthetic data, make ourselves familiar with the process workflow of the interconnected systems involved in this project, and acknowledge that with a rapid prototype, we might have to throw away code or start over from scratch. Since this was a proof of concept rather than a turnkey production system, it was critical to avoid any scope creep.
The State of Utah Directory of Clinicians will have records of deceased health practitioners in a PostgreSQL database. We extract data from the database using appropriate queries and parse to a FHIR JSON object. We then pass the JSON object to the Medicaid server, creating a FHIR patient resource. These activities could have been event-driven, but based on the inclusion of a static database server, it made more sense to engineer this as a scheduled job.
Our biggest challenge was authentication in the form of OAuth. Smart on FHIR was our initial target, which uses OAuth by default, and led to some initial challenges testing interoperability. We switched to FHIR servers that require less authentication. In a firewalled environment, authentication isn't as important, and we wanted to be able to test interfacing with multiple FHIR codebases. Our mentors suggested using the practitioner resource because it correlates to our real-world entity. It turns out practitioner resources are immortal. They don't even have a death date. We investigated workarounds within the current data structure, and after discussing with our mentor, changed to a patient resource since it has a death date in its definition. We worked on some experimental code for using a custom practitioner object, and it could be enabled if desired. Next, Tony is going to provide a brief demonstration of the work we've accomplished.
So what we're going to do is do a little demonstration of our DOH to FHIR Python application. The idea is that we're going to be taking data from a Department of Health database, and I've got an example of some of the data we have right here, and we're going to be moving it to a FHIR server. In this case, this is the University Health Network of Toronto's open FHIR server. And I'm going to be using the history button here to talk about how the data has been updated. So if I click on this history button, this is going to give me everything that's happened in the past hour, and I can click on a patient here. I find out Gina Smith was the last patient who was added to this. So we're going to create some patients. So I'm going to do Python, DOH to FHIR.py, and I'm going to start with Alexis Jensen. Alexis Jensen is the first person on this database here. So I'm going to hit enter. It's going to tell me it's processed one patient, Alexis Jensen. And now if I go to the history button, and take a look at the most recent patient we've got here, I see Alexis Jensen. I see her birth date is on here as well. Let me scroll over to that. So I can see her birth date of February 11th, 1967 right here. I can see that she also has this ID here. This is actually her provider ID, which we've got here as an identifier of value. So it can be searched through, searched on the FHIR server as that. So I'm going to go back. I'm going to talk about another thing that we can do. So I'm going to use this again, but instead I'm going to talk about a particular date. I'm going to talk about December 8th, 2016. And when I do that, I'm going to find one person. I'm going to find Catherine Foe. And so now if I hit this history button and go to the last patient that was added to this database, I'm going to find Catherine Foe. I'm going to see all of her information here. I'm going to do the same thing with a range of dates now. So I'm going to choose from September 2nd, 2016 to September 5th, 2016. And that should give me these three individuals here, this Tamletha Wimmer, Colby James Tiny, and Brent James. So if I do that, I should see that it creates 3 patients. And if I go to history, I'm going to go ahead and reveal these 3 patients here. And I see that I've got Tamletha Wimmer, I've got Colby James Tiny, and I've got James Brent. So some other features that we're going to do, I'm actually going to do it by the Department of Health ID number. So it's going to be 5797226-1588. And that should be this person here on line 6, which is going to be Gilbert, Thade Gilbert. So I'm going to process that data. I see Thade Gilbert has been transmitted. And if I go to the FHIR server and take a look at the most recent patient, I see Thade Gilbert has been added to the FHIR server. So I want to do one more example here. I'm going to do Python doh to FHIR.py, and I'm just going to type in Jones. And I'm going to show that if we do it just by last name, in my list here, I actually do have 2 people with the last name Jones. I've got Jorge Jones and I've got Susan Jones. So if I run this, I'm going to see that Jorge and Susan have been added to the FHIR server, and I can verify that by taking a look at the most 2 recent patients, and I see there's Susan and there's Jorge.
The biggest lesson we learned from this project was to get technical resources, such as web servers and databases, stood up as early as possible. Most of the issues we encountered from the beginning were due to making unfamiliar choices and hoping they would meet our needs. We also thought we adequately covered the requirements after our first meeting with our mentors, and while we did get clarifications, we could have asked for them earlier. Fortunately, these were quickly resolved over email, so collaborating with our mentors was painless.
The code for our project is available on our team's GitHub, which is linked below. Any prerequisites needed to run it are listed in the product documentation. We've also tested it against quite a few FHIR servers that we've created on our own or found on the internet, proving that FHIR provides fast and easy interoperability.
Thank you so much for watching, and more importantly, for giving us this learning opportunity.
Thanks for watching. We look forward to reading your feedback.